Alright, so welcome to my third video on physics basics. Today we're going to be doing simple conversions from one unit to a different type of unit, or simple things like standard form and the SI units. Anyway, let's jump straight into it. Make sure that when you're watching this video, just don't watch it. Make proper notes. Alright, so let's start off with a very simple question here. Look on this side of the board. Right. So I'm sure everybody has encountered a situation at some point where they needed to convert centimeters into meters or meters back to centimeters. Now usually when you're converting from one unit to the next unit, you're either going to be multiplying or dividing. And a lot of students, I've seen it over and over, sometimes they multiply by mistake when they should be dividing. So this here is a general rule of thumb. Whenever you're converting a smaller unit to a bigger unit, you will have to divide. And if you're converting a bigger unit to a smaller unit, you will have to multiply. Alright, so we're going to go with some basic assumptions that you know that there are 100 centimeters in a meter. So that's my starting point for this video. So if I want to convert centimeters to meters, right? Centimeters is smaller and meters is bigger. So a lot of students will ask themselves, hey, should I multiply by 100 or divide by 100? So if you have a certain amount of centimeters and you want to convert it to meters from smaller to bigger, you will have to divide by 100, not multiply by 100. And if you have meters, for example, let's say you have 5 meters and you want to convert it to centimeters, you would have to multiply by 100 because meters is bigger than a centimeter. You are going from bigger to smaller. So this one is pretty simple. I'm pretty sure most of you all knew that already. But here's one that gives some problems. A lot of people think centimeters and centimeters squared is basically the same thing. They are not the same thing. Centimeters and meters are used to measure lengths. Centimeters squared and meters squared are used to measure areas. Now, it's pretty obvious that a centimeter square is smaller than a meter square. So when you are converting centimeters squared to meters squared, we have to divide. But the mistake students make, they still divide by 100 because they still think centimeters squared and centimeters is the same thing. So other students will say, well, it's a square. So I'm going to, instead of dividing by 100, I'm going to divide it by 200. That is also wrong. In fact, you have to divide it by 100 squared. And 100 squared is 100 multiplied by 100. So you're already dividing it by 10,000. And anytime you're converting meter squared back to centimeter squared, you multiply by 10,000. Alright, so make sure and make proper notes. To save time in the exam, just remember it. Centimeter squared to meter squared, you divide by 10,000. That's a 1 with 5 zeros. If you are converting centimeter cube to meters cube, and the cubes are a measurement of volume, you would have to divide not by 10,000, but divide by 100, a next 100, and a next 100, making it 1,000,000. And to convert meters cube back to centimeters cube, you multiply by 1,000,000, right? So I hope that sticks in your head there. Okay? So don't mix up the centimeters to meters and centimeters squared to meters squared. Oh, and I made a mistake. I said 5 zeros. This is a 1 with 4 zeros. A 1 with 4 zeros. My mistake. Sorry about that. Okay? And the million is the 1 with the 6 zeros. So that's pretty simple. Make proper notes. So let's do another popular conversion on the CXC syllabus. When you're measuring velocity or speed, there are two units you usually encounter: kilometers per hour and meters per second. Both of them can be used to measure speed or velocity. Whenever you have to convert kilometers per hour to meters per second, right, you need to multiply by 1,000 and then divide by 3,600. The reason is 1 kilometer has 1,000 meters and 1 hour has this amount of seconds. If you don't believe me, you can sit down one day and count in 1 second for an hour, and I bet you will come up with this number. And if you want to convert meters per second back to kilometers per hour, you just do the opposite. Instead of multiplying by 1,000, you multiply by 3,600 and then divide by 1,000. So let's do a couple of examples for this one here. All right, let's say I have a car and the car is moving at 25 kilometers per hour. And for some reason, the examiner has asked you not to use kilometers per hour. Instead, they want the speed in meters per second. Well, all we need to do is we're converting kilometers per hour to meters per second. So we multiply the value, which is 25, by 1,000 and then divide it by 3,600. Let's see what we get. 25 multiplied by 1,000 divided by 3,600. And we'll get 6.94 meters per second. So 25 kilometers per hour is this same amount in meters per second. Right? And let's do one opposite example. It's pretty straightforward, guys. It's one of the easiest videos that you're going to encounter with me. Let's say you have a car moving at 13 meters per second. And the examiner, for whatever strange reason, wants you to convert it to kilometers per hour. Well, let's just follow these instructions here. We just multiply by 3,600 and then divide it by 1,000. So let's do that on the calculator. 13 multiply by 3,600 divide by 1,000. And we get 46.8 kilometers per hour. All right. So guys, please make notes as I do these questions. Just watching it alone is not enough. You need to make notes and constantly revise them. And of course, practice lots of questions with them. All right. So make some space here. So we have kilometers per hour and the meters and centimeters. All right. Now I have some harder stuff to do, but I need to go through some basic maths here with you. 10 squared. How much do you think 10 squared is? That's an easy primary school question. 10 squared is 100. 10 squared is just a 1 with 2 zeros. So how much is 10 to the power 3? This should just be a 1 with how much zeros? 3. 1, 2, 3. 1,000. So 10 to the power 6 is just a 1 with how much zeros? 1, 2, 3, 4, 5, 6. Alright? Pretty straightforward. That may be obvious. So if I have 5 multiplied by 10 to the power 6, this is just really 5 multiplied by a 1. Never 10 to the power 6 is a 1 with how much zeros? Alright? And 25 here multiplied by 10 to the power 3 is just 25 multiplied 10 to the power 3 is a 1 with 3 zeros. And of course you can use a calculator just to multiply it out. Alright, now what I'm getting at here is how they actually use the calculators. So that was the main aim here. I just want to show you how to type it in now, because a lot of students they get really confused with it. Alright, let's see, we'll line up everything here, make sure you can see everything. Nope, can't. Alright, should be easier here. So I want to show you how to type in 5 multiplied by 10 to the power 6 on your calculator, right? Different calculators, slightly different ways, but most of my students use the sharp DAL here. So 5, and when you want to put multiply by 10 to the power something, which is very popular in the exam, you will see an EXP button. Let me see if I can get it here. somewhere over here, a button marked EXP. So let's try it back here. 5, and when you press the EXP button, in the corner here, the calculator will automatically write in multiply by 10, and it's waiting for you to just insert the power. So let's go through back that again. 5 EXP, and after I press the EXP, I just need to press the 6 to indicate the power above the 10, and you just press equal, and you will see a 5 with 6 zeros up here. So let's do this one. 25 EXP. The calculator writes multiply by 10, and it's waiting for you just to input the 3. Bam. Let's do one more here. I actually have a couple more to do with you all. How about this one? I'm going to type in this number here, 0.00035 EXP 9. Bam. And I get 350,000. So I'm just showing you how to use your calculator. Right. Now, if you notice, all of these powers here are positive numbers. We're more accustomed with positive numbers, and ask any students if they prefer positive numbers to negative numbers. They will choose the positive numbers because positive numbers are much easier to deal with. But let's say I had 62 multiply, well, let's start with something easier. 10 to the power 2 is, remember, a 1 with 2 zeros. But what does 10 to the power minus 2 mean in maths? Well, this means 1 divided by a 1 with 2 zeros. So 10 to the power 2, if I had something here, it means we'll be multiplying by 100. But 10 to the power minus 2 means we are dividing by 100. So if I have 10 to the power minus 6, this is really 1, and underneath I have a 1 with how much zeros? 1, 2, 3, 4, 5, 6. And of course, if you divide something by 100 or divide something by 1,000,000, it will get smaller. So whenever you see negative powers above the 10, that means we're dealing with very small units. Okay? So just as an example, let's say you had 325 multiplied by 10 to the power minus 3 in the exam. And you needed to type that in on your calculator. It's very simple. It's almost the same procedure. Type in the 325. You multiply by 10, that's the EXP button, and it's just waiting for you to type in the minus 3. So you don't use this minus sign, you use the plus or minus sign. I just call it the funny button. Minus 3. Right, so the power I'm typing is minus 3, and you press equal, and that is 0.325. So this is the same thing as 0.325. Easy enough? Let's try the next one. Let's say you had 950 multiplied by 10 to the power minus 6. So, let's try this. 950 multiplied by, sorry, I shouldn't have pressed the multiply. 950, press the EXP button. The EXP button automatically puts in the multiply and the 10 for you. And it's just waiting for you to type in negative 6. Remember, you're going to use the funny button, the plus or minus button. And that's equal to 0.00095. 0.00095. Alright, so you'll be surprised of how much students have trouble just using the buttons on the calculator. When you're inside a full class, like half the class will know, half the class will not know, and the teacher has to pause again to go through this whole thing or walk around individually. So let's try some harder examples here involving the EXP button. Right? Alright. Let's say you had this calculation to do. 495 multiplied by 10 to the power minus 6. Multiply by 3 multiplied by 10 to the power 8. Alright, so how are we going to do this question? Let's remove the brackets. We want to take this entire expression and multiply by this entire expression. Now, to be safe in the exam, actually, let's just type it in. Sometimes, if I have two complicated items and I want to type it in, I will put one of the item in brackets and the other item in brackets to kind of isolate both of them. Let's see. Let's try it without the brackets and see if we get the same answer as with the brackets. So without the brackets first. 495 EXP, and that is it put in the multiply by 10. Let's type in -6 multiply by 3 EXP, and we're going to type in a +8, and we get 148,500. Let's try it with the brackets on this calculator and see if we get the same answer. So I'm going to put this entire item in brackets. So open brackets, 495 EXP, -6, close brackets, multiply by open brackets, 3 EXP, normal +8. We get the same answer. So whether we use brackets or don't use the brackets, on this type of calculator, we get the same answer. Alright? So obviously we can do this for multiplication, we can do this for division. So what I'm going to do, I'm going to explain this chart to you all now. Alright, remember we were using, in a lot of these examples like this one here, I was saying 10 to the power -6. Also, when I think this was the other one, 450 multiplied by 10 to the power 3. Instead of writing multiply by 10 to the power -6 or multiply by 10 to the power +3, you can write it slightly different and it would mean the same thing. Alright, so let's start off with the most popular one. This guy here. Hope you all can see this properly. Let me angle it here. I think this is the most popular one. Kilo. Kilo, the symbol for kilo is K, and kilo really means 10 to the power 3. Now we know 10 to the power 3 is the same thing as a 1 with 3 zeros, better known as 1,000. Now why I say this is the most popular one, we've all heard something with kilo, a kilogram. Right? Right? So a kilogram means what? 1,000 grams. Or a kilometer means 1,000 meters. Sometimes you say kilometer, a lot of students, and they have no idea that they're really saying 1,000 meters. It's just a name to them. Kilometer. You just say it over and over, not realizing what it really means. So kilo, very popular. But there are other ways. So let me erase this here. So let's try another one that doesn't involve something so popular. Let's try this one here. Mega. Right? Now, you may not be familiar with this, but there's something called a force. A force is measured in something called newtons. And the symbol for newtons is capital N. So when you push somebody or pull something, you pull it at a certain force. Let's say that force was 2,000 newtons. So you pushed somebody at 2,000 newtons. Instead of saying 2,000 newtons, you can say 2 kN. What does the K stand for? The K stands for kilo. So, and remember what kilo means. Kilo really means to the 10 to the power 3. So this is really 2 multiplied by 10 to the power 3 newtons. But we know 10 to the power 3 is 1,000, and 1,000 by 2 will give us back the 2,000. So 2 kN, but which one looks neater here? Which one looks neater? Doesn't this one look neater? Instead of having all these zeros, the 3 zeros, you can just put KN, right? It looks neater. So from the chart, let's see. Let's do a few examples and we'll find them together. let's say that I had a very small force, and the size of this force was 625 micronewtons. Now everything doesn't have to be about force, I'm just saying. Let's look for micro on this chart here. Micro, where's micro? Micro is not here. Hey, look, micro is over here. Micro really means to multiply by 10 to the power minus 6. Now, this is not positive 6. This is minus 6. So, 625 micronewtons really means 625 multiplied by 10 to the power minus 6 newtons. You can throw away the micro symbol and put that in its place. And of course, we can type it in our calculator if we wish, right? If we're required to. It's pretty simple. 625 exp negative 6, the funny button. And that's this in normal newtons. 0.000625 newtons. All right? So I would really like you all to make a note of the chart. Now, there are a few that I've never seen come in the CXC exam. I've never seen this one come. I've never seen ATO. I've never seen FEMTO come. I've actually never seen DESI come either. But so I would prefer if you drew back this chart. Now you notice this tree is different from this tree. Everything here is the negatives. Everything here is what? The positive. I've also never seen deca or hecto come. So please pause the video and take down this chart here. So if you see nano, that means multiply by 10 to the power minus 9. If you see pico, it means multiply by 10 to the power minus 12. And I think you get the idea here. You notice here's the symbols are a little bit different here. For Peter, it's capital P. For pico, it's common P. So make sure you get the letters correct as well. The capital and the common. All right. So in a few seconds, I'm going to do a lot of examples involving switching from, like, we'll be forced to use this chart to get out the questions. All right, so let's try some examples involving this chart here. Okay, now I'm going to assume that you wrote this chart down. I know it's kind of far away from the camera, but I really need the space to work, right? So if you didn't copy down the chart, rewind a little bit and copy it down. All right, so I'm going to explain this using some formulas here. Let's say that we have this formula here. If you have never seen it, that's okay. I'll explain it a little bit. This formula relates pressure, force, and area. I think you have an idea of a little bit of what pressure. Let's say I were to take this marker and press it down on the board itself. Obviously, if I'm pressing down on it, I will be creating a pressure on the board. Now, if I push down this marker at a certain force, and the bottom of the marker has an area, when the force pushes down on the area, you get a pressure. Okay? Now, and this here is the formula that relates the whole scenario. If I want to calculate pressure, I just block the P. Pressure is force divided by area. If I want to calculate the force, I block the force and you get pressure multiplied by area. Right? So the important thing to remember here is pressure is measured in something called pascals, and I will eventually do a whole video on pressure. And force is measured in something called newtons, and area for this formula should be in meters squared, not centimeters squared. So let's say one day I ask you to find the pressure, and I told you, well, this is a different color marker here, and I told you the force was 680 kilonewtons. Now you notice I did not give the force in normal newtons. I put Kn, and K stands for kilo, which means multiply by 10 to the power 3 or 1000. Right? But I'm going to put the 10 to the power 3 when I'm using the calculator. But I'll get to that just now. And let's say that the area was 45 meters. Sorry, let's make this a little bit harder. 4,500 centimeters squared. So I give the force not in irregular newtons, and I give the area in centimeters squared rather than what? Meters squared. So let me do the wrong thing first so you get an idea of what not to do. So here's what a lot of students do. They want to calculate pressure, they block the P. Pressure is just force divided by area, right? Fair enough. Pressure is force divided by area. They look for the force, they see a 680. They pay no heed to the K. They just see 680, so they put 680. And they see an area of 4,500. And they just put 4,500. So, they go on their calculator, type in 680 divided by 4,500. And when they do that, you can make sure you work this question with me. They get 0.15, and pressure is measured in pascals. And they think, well, they got everything correct, and they leave the exam thinking they got full marks. This is wrong. Let me explain why. First of all, right, for this formula to work, this 680 has to be in newtons, not kilonewtons. But we know what the K means. The K means multiply by 10 to the power 3. So the actual force is 680 multiplied by 10 to the power 3. Now, I could take my calculator now and work this out, but let's leave it just so for the time being. This centimeter squared needs to be converted to meter squared. Do you think you can remember from the beginning of the video how you convert centimeter squared to meter squared? You're going from smaller to bigger. That means we'll have to divide by 10,000. Remember, squareds. If it wasn't squared, you would have to divide by 100. But when converting centimeter squared to meter squared, you divide by 10,000. You divide by 100 twice. So, this 4,500, before we move any further, we should divide it by 10,000 to convert it to meters squared, and then throw it into the formula. So 4,500 divided by 1, 2, 3, 4 zeros there, right? And how much we getting? 0.45. But this 0.45 is in meters squared. So the real area is 0.45. Right? Remember, for certain formulas need certain types of units in order to work or to get the correct answer. So let's type this in our calculator now. 680 multiplied by 10 to the power 3. I just press my EXP button, type in the 3, divide by how much? 0.45. And the real answer is 1, 5, and there's 1, 2, 3, 4, 5 ones there. 0.11. And this is the answer in pascals. Alright? So, this answer is way bigger than the wrong answer we got previously. Let's try another example. So let's try the next example here. Okay, here's another formula that you will meet up very soon in physics. This formula relates three things: velocity, frequency, and wavelength. Right? You'll meet this formula when you're doing a topic called waves. Alright, now the actual theory behind the formula isn't too important. All you need to know is, for this formula to work, the velocity must be in meters per second, not kilometers per hour. Frequency is measured in something called hertz, capital H and Z. And wavelength should be measured in meters. So let's say one day the examiner said, hey, I want you all to calculate the velocity of a certain wave. So to calculate velocity, you need to take the frequency and multiply it by the wavelength. So he gives you the value of the frequency and the wavelength. So let's say the frequency is 450 capital M H Z. Capital M is over here. That's mega. Mega means multiply by 10 to the power positive 6. Right. But for this formula to work, it has to be in hertz. So we need to take this m and change it to multiply by 10 to the power positive 6. Then he comes and gives you the wavelength. But he doesn't give you the wavelength in normal meters. He puts n, common n and then m. Common n is nano, which means 10 to the power minus 9, right? So this is minus 9. So you need to calculate the velocity, you need to take the frequency and multiply by the wavelength. The frequency is 450 megahertz, but mega really means 10 to the power positive 6. So I have to replace this m with multiply by 10 to the power positive 6. Then I have to multiply by the wavelength, but nanometers means 820 multiplied by 10 to the power negative 9. So we just need to multiply this out now, and we will get the velocity in meters per second. So let's do this. 450 multiply, when you see the multiply by 10 to the power something, you press the exp, press positive 6, multiply by 820 exp negative 9, and we got a nice number. Looks like 369 meters per second, because velocity is measured in meters per second. So, but let's just say that the examiner said that he did not want the answer in meters per second. Let's say he wanted the answer for velocity in kilometers per hour. You already know from a little previously how to convert meters per second to kilometers per hour. So how would you convert this to kilometers per hour? To convert meters per second to kilometers per hour, you multiply by 3,600 and then divide it by 1,000. Alright? That's if he wanted it in kilometers per hour. So let's see, 369 multiplied by 3,600 divided by 1,000. If we did the conversion, it would be 1328.4 kilometers per hour. Right? And I have seen questions like this where the formula gives you your answer like in meters per second, and in like part C or D of the question they ask you to convert that same answer to kilometers per hour. And you'll be surprised how much students forget the formula to convert from meters per second to kilometers per hour. Alright, let's try another example using a formula here. Alright, so let's try this example now. Here we have a very famous formula in physics. Energy is equal to mass. In between here and here there's a secret multiply by c squared. Now, in case you don't know what c stands for, c stands for the speed of light, and it's a standard value you need to learn off. The value is 3 multiplied by 10 to the power 8 meters per second, right? So that's the speed of light in meters per second, not kilometers per hour. So for this formula to work, the energy should be given in regular joules, right? Energy is measured in something called joules, capital J. The mass has to be in kilograms. So let's say that the examiner wants us to find in this question the mass. So he gives us the value of the energy. Let's say the value of the energy was, as I wrote it down here, was 120, but he didn't put regular joules. He put capital G and then the J. The capital G stands for giga, and giga means 10 to the power 9. So, and remember, the speed of light is a standard value you need to learn off. So we need to find m, which means that we need to get m on one side and everybody else on the other side. So this c squared is a multiply. When we throw him across, he will become a divide. And it's also important to know this squared only belongs to the c. It does not belong to the m. So let's transpose this formula. I'm just writing the M on this side, but the E is here, and when you throw across the multiply, it becomes a divide. So the C squared actually ends up underneath. So let's plug in the values. The energy was 120 giga, but giga means multiply by 10 to the power 9. So I throw away the G and replace it with that. And this C squared, but you see this whole value has to be squared. So how do you write that? I would really recommend you put it in brackets. So the speed of light is 3 multiplied by 10 to the power 8. Close brackets. It's very important you close the brackets and then you square it, right? Pause the video, look at it for a few seconds, make sure it sinks into your head. Close the brackets and then square, because you want to square this entire value. So how would you type this in on your calculator? I think I should zoom up for this one. Let's hope nothing gets blocked out. Everything is clear there? Alright. Let's clear the calculator here. Right, so I'm going to type in the top first. 120 multiply, 120 exp 9 divided by open brackets, that's this guy here, 3 exp, and I just have to type in the 8, close the brackets, and then I squared. I have a squared button here, and I press equal, and that's my answer. That's the mass. That 0.000001333, and that answer is in kilograms. All right, so I really hope this this video helped you to understand the SI units and how to even the standard form, the multiple, and how to use your calculator and whatnot. Right, so watch it over and over. Make sure you make proper notes. I guarantee you, when you step into a physics class, everything is going to be so much easier for you. All right, okay guys, take care.